Solving systems of equations in three variables. When we introduce a third variable, it is the variable z. When graphing, its axis would be straight up and down through the origin to make the graph 3D. The solution to a system in three variables is an ordered triple, x, y, z. We always put them in alphabetical order. There's three possibilities, so when you introduce a third dimension, two variables create what's called a plane. It's like, imagine it like a flat sheet of paper, a rectangular flat sheet of paper. So those three sheets of paper could intersect in one single point, and so then we'd have exactly one solution, or they could intersect in an entire line. So here we have where the three are intersecting in a line, or they could not intersect at all. Two of them could, but then no place to all three, as you see here, or they could all be parallel planes. Elimination method for a three-variable system. Step 1. Rewrite the linear system in three variables as a linear system in two variables using the elimination method. You will need to do this with two equations at a time. Then you solve the new linear system for both of its variables. And step 3, you're going to substitute the values found in step 2 into one of the original equations and solve for the remaining third variable. If you obtain a false equation, such as 0 equals 1 in any of the steps, then the system has no solution. If you do not obtain a false equation, but obtain an identity, such as 0 equals 0, then the system has infinitely many solutions. That's when it intersects in the line. So, example 1. X plus 2y minus 3z equals negative 3, 2x minus 5y plus 4z equals 13, and 5x plus 4y minus z equals 5. First thing I like to do is label them, and I'm going to use letters to do this. So I'm going to label them A, B, and C. Now I'm going to think about which letter would be easiest to eliminate first. So right away I see this 1x, which means it would be pretty easy to scale to whatever value I need. So I'm going to start by pairing these two equations and multiply this top one by negative 2. So I'm going to do negative 2 times the A equation, and that's going to give me negative 2x minus 4y plus 6z equals 6. And then I'm going to keep equation B exactly how it is. 2x minus 5y plus 4z equals 13. And we're going to add straight down, because negative 2x plus 2x is 0, and they're eliminated by design. Negative 4y and negative 5y gives us negative 9y. 6z plus 4z gives us 10z. And then 6 plus 13 gives us 19. So I'm going to call that equation D. And now I have to use equation C. I haven't used it yet, and I have to eliminate the exact same variable I did the first time. So I got rid of x, I got to get rid of x again, so I'm going to pair it with equation A, so that again I can easily scale up equation A. So this time I'm going to do negative 5 times equation A, and I'm going to get negative 5x minus 10y plus 15z equals positive 15, and I'm going to keep equation C exactly how it is, 5x plus 4y minus z equals 5. And I'm going to add straight down. Negative 5x and 5x is 0, so they're eliminated by design. Negative 10 plus 4 gives us negative 6y. 15 plus negative 1 gives you 14, and 15 and 5 gives you 20. Now I notice right away that these are all even numbers, so I'm going to go ahead and reduce this entire equation by 2, so that I have negative 3y plus 7z equals 10, just to make it a little easier to work with, and I'm going to label it equation E. So now equations D and E have only two variables, and they're the same two variables, y, z. That's an important checkpoint. When you get equations D and E, you need to make sure they have two variables and they're the same two variables. If you don't, you got to go back and redo your elimination method to make that happen. So now I'm going to pair up D and E and eliminate another variable. So I notice that I've got 9 and 3 multiples of each other. So I'm going to keep equation D as it is, but I'm going to multiply equation E by negative 3. So that I get positive 9y minus 21z equals negative 30. And we're going to add straight down. 10z take away 21z gives us negative 11z. And 19 take away 30 gives us negative 11. So we divide by negative 11 to see that z equals 1. So we found the value of our first variable. Now we're going to take that and plug that into either equation, D or E. I'm going to plug it into E just because I have room underneath equation E to do that. So I'm replacing Z with its value, which is positive 1. So I have negative 3y plus 7 equals 10. So negative 3y equals 3. When I subtract the 7 from both sides, I'll divide by negative 3 and see that y equals negative 1. And then I'm going to take these two values and head all the way back to the beginning. I need to solve for x, so I'm just going to go ahead and use equation A. You can use any of the equations. You should get the same values no matter what. If you don't, you know somewhere you're wrong, because these values have to work in all three equations. So x plus 2 times that y value minus 3 times the z value has to equal negative 3. So x minus 2 minus 3 equals negative 3. X minus 5 equals negative 3. So x must equal 2. And so that gives us the ordered triple 2, negative 1, 1, because you have to put them in order x, y, z. And we should plug that in, make sure it works in all three equations. In the first equation, 2 plus 2 times negative 1 minus 3 times 1, does that equal negative 3? Well, 2 minus 3, we get 0 minus 3, negative 3 does in fact equal negative 3, so it checks in the first one. If we check in the second one, 2 times 2 minus 5 times negative 1 plus 4 times 1. That gives us 4 plus 5 plus 4, which is 13, so that checks. And if we plug into the last one, 5 times 2 plus 4 times negative 1 minus 1, we get 10, take away 4 minus 1, which is 5. So it checks in all three equations. So remember the steps. You want to start by pairing the equations up 2 at a time and eliminating the same variable. So, glance at the equations overall, decide what's easiest to eliminate. I decided to go for the x's, so I scaled matrix A up by negative 2 and combined it with B. And then I took equation A and scaled it by negative 5 and combined it with C. So then I had two equations that now just had a y and a z in them. And then I could pair those two equations and eliminate the y's by scaling up this one. Then I solve for z. I take z, I plug it in to one of my two equations, either D or E, that only have y and z in them. Solve for y, and then take y and z, plug it into one of the original 3 equations to solve for x. Then write your answer as an ordered triple, x, y, z. Here's another example. 3x plus 2y plus 4z equals 11, 2x minus y plus 3z equals 4, 5x minus 3y plus 5z equals negative 1. So I'm gonna start by labeling them so I know which equation I'm using when. So equations A, B, and C, and I immediately notice, oh, we've got a negative 1y, so that would be easily scaled up to a 2 or a 3. So I'm going to work on eliminating y first. So I'm going to keep equation A just how it is. And I'm going to take equation B and multiply it by 2. So that I'll have 4x minus 2y plus 6z equals 8. I'll add straight down and get 7x, 2y plus negative 2y is 0. Eliminate it on purpose. 4z plus 6z is 10z. 11 plus 8 gives you 19. Can't reduce that at all, so I'll just leave it the way it is and call that equation D. Now I'm going to take equation C and I'm going to leave it just the way it is. I'm going to multiply equation B by negative 3 so that I can have a positive 3y to cancel out with the negative 3y. So 2 times negative 3 gives me negative 6, negative 1 times negative 3 gives me positive 3, 3 times negative 3 gives me negative 9, and 4 times negative 3 is negative 12. Remember, every term in the entire equation must be multiplied by whatever it is you're scaling up. So we can't forget the constants over here. Okay, so now I add straight down. 5x take away 6x gives me negative 1x, negative 3y plus 3y. 0, they're eliminated. 5z minus 9z is negative 4z. Negative 1, take away 12, gives you negative 13. And that's equation E. And now here's your first checkpoint. You need to make sure you have 2 equations with 2 unknowns, 2 variables, and they need to be the same variables. So this one has x and z, so does this one. If it doesn't, you need to go back and rework what you did. You have to make sure you eliminate the same variable from both sets of elimination. So you also have to make sure all 3 equations are used. So here we used A and B, here we use C and B. So now I'm going to pair up D and E. I notice this negative 1x would easily be scaled to eliminate the x's. So I'm going to take 7 times equation E, put it under equation D, so I'll have negative 7x minus 28z equals 21. Negative 91. 7 times 3 is 21, carry that 2, 7 times 1 is 7, plus 2 is 9. Then we add straight down, 7x plus negative 7x is 0. 10z, take away 28z is negative 18z. So we think through this, 91 minus 19. We know it's going to come out negative because the bigger one's negative. 11 minus 9 is 2. Would have taken 1 from the 9, so 8 minus 1 is 7. So if we divide by negative 18, z equals positive 4. So now I'm going to take that and plug that into equation E. I could plug it into either D or E, it's just that I have room underneath equation E, so that's where I'm going to do it. So I have negative 1x minus 16 equals negative 13. Divide by the negative 1 to see that x equals negative 3. And I'm going to plug those 2 values into one of the original equations. It doesn't matter which one. All 3 should give me the same answer. If they don't, I've done something wrong. We have to solve for y, so any of them I'm going to end up dividing. So I'm just going to use equation A. So in equation A, 3 times the x value of negative 3 plus 2 times the y value I'm solving for plus 4 times the z value equals 11. So negative 9 plus 2y plus 16 equals 11. So 2y plus 7 equals 11. So 2y equals 4. And y equals 2. So I have my three values, so my order triple is negative 3, x, y, z, alphabetical order always. So negative 3, 2, 4. That's my solution, and then I just need to check it. So since I used equation A to find the y value, I'm going to check it in equations B and C. So 2 times the x value minus the y value plus 3 times the z value equals 4. So let's see if it really does equal 4. 4 equals 4. Check. And you need to do this. You need to check that it really does work in all three equations. So equation C, 5 times the x value minus 3 times the y value plus 5 times that z value. See what we get there. We get negative 15 minus 6 plus 20. We need to check to see if that equals negative 1. Well, negative 15 take away 6 more is negative 21 plus 20. Really does equal negative 1. So it checks. And we know that we have the correct solution. So these three planes intersect at a single point, and that point is negative 3, 2, 4. Okay, so one of the applications for solving systems in three variables is to find the equation of a parabola when you just have random points on that parabola. If we were given the vertex and one other point, we could use vertex form. But if they just give us 3 points and they don't tell us that they are the vertex, and we don't have the two x-intercepts, our only option really is standard form, or to use one of the other forms, but still you're going to have to do some pretty sophisticated algebra to figure it out. So here we go. We're giving you 3 points on the parabola, negative 3, 10, negative 1, 0, and 2, 15. So we have one x-intercept, but not the other one. And we don't have the vertex. So we're going to find the standard form. Remember, it's ax squared plus bx plus c, and ordered pairs are always an x value and a y value. So we're going to plug them in. So when y is 10, the x value is negative 3. Keep in mind this exponent only applies to the x, not its coefficient a. We're going to be solving for a, b, and c. And so we simplify this. We square the negative 3 and get 9 times a is 9a. Negative 3 times b is negative 3b plus c. Okay, so that's capital A. That's our first equation. The next point, when y is 0, x is negative 1. So I'm replacing my x's with negative 1, and my y value is 0. I simplify, negative 1 squared is 1, times a is a, minus b plus c, and that's capital B. And then our third equation, when the output is 15, the input is 2. So 2 squared plus b times 2 plus c. So 15 equals, 2 squared is 4, times a is 4a, plus 2b plus c. So I have my three equations, and when you're doing this type of problem, you'll always have plus c. That'll never change because c is not multiplied by the x value, so it's unaffected by the input. So that's what you want to eliminate when you're solving these. Always try and eliminate the c value first. So to do that, I'm going to take negative 1 times equation B and put it under equation A. So I'll have 0, because 0 times negative 1 is still 0, negative A positive b minus c. So that now I can add straight down. 10 plus 0 is 10. 9a take away 1a gives me 8a. Negative 3b plus 1b gives me negative 2b. And c plus negative c is 0. Eliminated on purpose. These are all even, so I'm going to go ahead and reduce it by 2 to make it as simplified as possible. And so that is equation D. And I'm going to do the same thing with equation C. I'm going to put negative 1 times b underneath. I move that over a little. So I'll have 0 equals negative a plus b minus c still. So I can add 15 plus 0 is 15. 4a take away a is 3a. 2b plus b is 3b. And c take away c is 0, eliminated on purpose. These are all divisible by 3, so I'm going to go ahead and reduce and get 5 equals a plus b. And that's equation E. And now I notice I've got a negative b and a positive b, so these are set up perfectly to eliminate. Remember, this is your checkpoint. Make sure you have the same two variables here as here. If not, go back and fix your elimination to eliminate the same letter both times. But I can just go ahead and pair these up. I don't even have to scale them by anything. And I can add straight down. 5 plus 5 is 10. 4a plus a is 5a. I get a equals 2. So I'm going to plug that back into either equation D or E. And I'm going to solve for the value of b. And then I'm going to plug those two into one of the original equations. So I have room under equation b. I'm just going to do it there. So we have y equals, plug in your solution here. We weren't looking for a point of intersection. We were looking for the coefficients for standard form. So you go ahead and plug them in. A was 2, so you're going to have 2x squared. B was 3, so plus 3x, and then your constant was 1. So the equation of that parabola, the standard form of the quadratic, is y equals 2x squared plus 3x plus 1. And you can check it, plug in your points, make sure they work. So when I plug in negative 3, I better get 10. Well, negative 3 squared is 9. So get 18, take away 9 plus 1, which gives us 9 plus 1 or 10. Check. Check the second one. When I plug in negative 1 for x, I better get 0. Negative 1 squared is 1. So when I do my multiplying, I have 2 minus 3 plus 1, which does in fact equal 0, so that checks. And then for the third one, when I plug in 2, I'd better get 15. So 2 squared is 4. A plus 6 is 14, plus 1 more is in fact 15. So it checks, and I have the correct equation for the parabola. So that's just one application of systems with 3 variables. Remember, star standard form, plug in your x values, plug in your y values, simplify to get your equations. Then pair them up 2 at a time and eliminate the c value, just because it's always going to be plus c, so it's easy to eliminate. That'll give you an equation in terms of a and b. Pair up the equation you haven't used yet with one of the first 2. Again, eliminate c, so you have an equation in a and b only. Pair up those 2, do elimination one more time to get rid of one of those variables. So now you can solve for one. Plug that back into either D or E to solve for another one, and then plug those 2 back into one of the originals, A, B, or C, in order to find your third variable. And if you are asked to find the equation of the parabola, you better make sure you answer the question. So plug them back in and tell us what is the equation.